In section 4.5, we're going to be talking about different forms of fractions. Okay, we're going to be working with what are called mixed numbers and improper fractions. Okay, so first, let me define a mixed number versus an improper fraction, and then I'm going to visually represent what they are. Okay, so first of all, a mixed number is called a mixed number because it has a whole number and a fraction. So an example of a mixed number would be 3 2/3, right? So this means that I have 3 whole pies and then 2 pieces of another pie, both of which are cut into 3 pieces because that denominator, right? And again, I'll represent this visually in a moment. Okay, an improper fraction, okay, is one where the numerator is bigger than the denominator. So looking at the one above, the improper fraction would be 11/3. So this is that I have pies cut into 3 pieces and I have 11 pieces, okay? So again, mixed number, you have a whole number and a fraction, and an improper fraction, you have a numerator bigger than the denominator. All right, another thing I'm going to remind you of is that fractions are division. And so we can actually use long division to convert or change between improper fractions into mixed numbers. All right, so visual representation. Okay, so let's look at, let's see. So I'm going to use the left-hand pictures to illustrate a mixed number. Okay, and then I'm going to use the second set to illustrate an improper fraction. Okay, so let's say that I had 2 pies, both of which are cut into 8 pieces. Okay, bear with me. I always joke, and I probably have in a video already somewhere. I always joke, this is not art, this is math. So please bear with me. I do the best I can, but I also don't grade based on artistic ability either. So I figure if I struggle, I'm certainly not going to punish those who do as well. All right, so mixed number. Remember, that refers to a whole number with a fraction. So let's say that I had all these pieces. And let's say that we had one pie that was completely eaten, right? So that's an empty pie. And then I have another pie that has, let's say, 3 pieces taken out of it. Okay, so just like any fraction, we have to look at how many pieces is each pie cut into. So for this first pie, it's cut into 8 pieces. And the next pie is also cut into 8 pieces. Okay? Well, we've taken, right, 8 pieces. So I'm going to put 8. But 8/8 equals 1, right? And then down here, right here, we have 3 of those pieces have been taken, so that's 3/8 of that pie. So if I were to put that together, I have 1 whole pie with an additional 3/8 of another pie. All right, so this is my mixed number. Now let's move to the other 2 circles, and I'm going to do the same thing. I am going to cut each pie into 8 pieces. Not drawn to scale. They're supposed to all be the same size. So again, bear with me. Doing my best. Okay. So again, each pie is cut into the same number of pieces. Here, I'm going to indicate that that whole pie is gone again. And then I have these 3 pieces that are gone. Once again, the denominator, right, is 8, and the denominator is 8. We already talked in the previous one that 8 pieces out of 8 are gone. And then we have 3 pieces, right, of the 8 that are gone. Well, an improper fraction is looking at what are the total number of pieces that are gone. Well, our denominator is still 8 because both pies are cut into 8 pieces, and then we add the total number of pieces. So the first pie, there were 8 pieces, and the second pie, there are 3. So that means we have a total of 11 eighths. So 11 pieces of pie out of pies that are cut into 8 pieces. That is my improper fraction. So that also means that 11 eighths is equivalent to 1 3/8. Okay, so the meaning of mixed number, a whole number with a fraction. The improper fraction is a numerator bigger than a denominator. The visual representation, right, of that is here with these 2 sets of pies. And now we're going to move to mathematically converting from one format to another. Okay, so converting is changing from one to the other. And remember, I mentioned that we have to keep in mind that fractions are division. And we can use that to figure out how many times the denominator goes into the numerator, right? And again, with mixed numbers, we're going to have the denominator go in at least one whole time because you have to have that whole number to be a mixed number, and then you have to figure out what's left over. So we're going to call upon a past strategy that we learned, and that's long division. Some of you may have a history of not loving long division that much, but practice, right? So if you get that ugh feeling when I mention long division, it just means that you're going to want to repeat this more, right? More the merrier. The more the practice, the more confident that you'll become. All right, so here's what we want to do. I'm going to go ahead and rewrite 3 halves, but write it as a long division problem. So long division, I have my symbol here. The number that goes into the numerator goes outside, right? And the number in the numerator goes underneath. So this is saying 2 goes into 3 how many times? Well, 2 goes into 3 one whole time. So that's 1 pie. And then we need to figure out, well, how many of the other pie, right, or other pies are included in this. So 1 times 2 is 2. So I'm figuring out what that leftover piece is, and that becomes 1. So 1 1/2. So in the past, when you first learned about long division, let me write this again, you would have learned 2 goes into 3, right? 1 times 2 is 2. Subtract, you get your 1, and you write remainder of 1. But instead of the remainder of 1, we're showing it as a fraction. And once again, when a pie starts out cut by 2 pieces, it's going to stay cut in 2 pieces. So your denominator at the beginning needs to be your denominator at the end. Okay, so that remainder is the numerator of your fraction, and the denominator just stays the same. All right, let's do the next one. So 7 goes on the outside because that's what you're dividing by, and that goes into the numerator. So 7 goes into 15 2 times. Remember, it's how many times it goes in without going over. So we have 2 times 7 is 14. We subtract, and we get 1. So instead of doing R1, we write, well, I have one piece of another pie that's cut out of 7 pieces, right? So my mixed number is 2 whole pies with 1/7 of another pie included. And that is your final answer. So go ahead and pause the video and try C, and then go ahead and watch and see how I finish it out. So remember, the numerator is divided by the denominator, and that's critical to remember for when you're setting up your long division. Okay, so 10, the number underneath, goes on the outside. 57 goes on the inside. Well, 10 does not go into 5. So now I have to say, well, 10 goes into 57 how many times? Goes in 5 times. 5 times 10 is 50. I subtract and I get a remainder of 7. So that means 7 is my numerator and 10 is my denominator. So my final answer is 5 7/10. All right, so visualizing is super, super important. And if you need to draw pictures to start visually connecting what's happening to what we're doing mathematically, I really encourage you to do that. That's why I start the video with a picture, because that can really be helpful for some people. All right, so we already were introduced to the fact that mixed numbers and improper fractions are equivalent to each other. So it's just another example of equivalent fractions written in different formats. So that means that we can go from improper fractions to mixed numbers and mixed numbers to improper fractions. We're reversing what we do, okay, for the converting to mixed numbers. So I like to show with symbols what I'm doing. So we take the denominator and we multiply it by the whole number. Once we do that, we add the result to the numerator. So 3 times 5 is 15, plus 2 is 17. So my numerator is 17, and again, my denominator stays the same. You have pies that are cut into 3 pieces. They will still be cut into 3 pieces. All right. A while back, we talked about what a negative in front of something means. We've talked about it related to exponents. So if you want to review that, I encourage you to go back and take a look at the exponent video. So what we want to do is get the negative away from that fraction. So in this case, the negative is just directional. It's saying how far is this number to the left of 0. So as you're calculating, that negative does not get incorporated. So the first step that I want you to do whenever you have a negative in front of a mixed number is I want you to rewrite it like this. You pull the -1 out, the parenthesis for multiplication, and then you rewrite your mixed number. Now you convert the 2 5/7 to an improper fraction, and then you multiply that by the -1. If you don't get the -1 out there, people very frequently multiply. So in this case, it would be 7 times -2, and that is incorrect. Okay, so this is the way to fix or reduce the chance of making that mistake. Factor out your -1 and then go ahead and convert. Okay, so I have 7 times 2, which is 14, plus 5, which is 19. So I get -1 times 19 over 7. And then my final answer needs to have that -1 put back in. So -1 times a positive 19/7 gives me -19 over 7. So you could write either -19 over 7, or you could do 19/7 and make that whole thing negative. Either is totally fine. Okay, so go ahead and pause the video, try C, and then turn it back on and see the process that I follow. All right, so looking at C, there is no negative in front, so that means I don't have to do that first step of factoring out the -1. So I'm just going to go straight to multiplying. So I have 3 times 4 is 12, plus 1 is 13. So I get 13 over 3. And that is my final answer.